So welcome, everyone. My name is Uday Hegde, and I am an architect in the Microsoft Identity team. And the topic for today is how you can, as a developer, how you can access Azure AD protected resources from your software workloads without using secrets. And this is possible in a few environments, and we'll walk you through that. And we call this feature Workload Identity Federation. So the agenda for today is first we'll define what exactly do we mean by workload identities in Azure AD. And then we will discuss this Azure AD Workload Identity Federation capability that is in public preview today. And we look at the 4 specific scenarios where we have tested it and it's available today. The first one is, if you're running in a Kubernetes cluster and your pods that need to access Azure resources, we'll walk you through how you can do that without secrets. We'll spend the most time here because I'll walk you through some specific examples and some very clear flows so that this scenario should be crystal clear by the time you're done. And then the rest of the 3 scenarios, we'll just look at them very briefly so that you get a good idea right up front what this is about and then how you can use it in the other scenarios. So the second scenario is how to use Swifty when, again, within a Kubernetes cluster, if you want, or even outside the Kubernetes cluster to access Azure resources. And then how you can use the same thing in GitHub CI/CD with GitHub Actions. And then finally, if you're running in Google Cloud, how you can access Azure from a service running in Google Cloud. So first, let's just define workload identities. I think it may be clear to many of you, but just so that we're all on the same page. If you look at the identities in Azure AD, I would break them into 2 distinct parts. One is the human identities, which we're all familiar with, which we use every day. And these are identities that employees that you give to your employees or even your external users through our Azure AD B2B flows or even through our B2C flows to your customers. And then there's a second form of identity called what we can call machine identities. And the machine identities have 3 very distinct type of things that are there. One is devices, and these are all handheld devices that you may bring into your work. So we provide policies such as user plus a known device. It may be it may be an Azure AD joint device like your Surface laptop, or it could be an iPhone, which is managed to Intune. So the user plus device is a flow that we support for devices. IoTs are another big trend that's happening that's slowly coming into the enterprise. And there's a bunch of things that our Azure IoT team does. And again, there are identities that are granted to these IoT devices. And then there are identities for software workloads. These are software components that you may be developing, that your developers may be developing in your companies. And these applications, web apps, script containers sometimes need an identity to go and access other resources. So workload identities are these when we say workload identities, we are talking about the last bucket here, which are identities required by software workloads to access resources. Just like users, these services also need identities. And you may be familiar with this concept of service principals in Azure AD. And there are 2 kinds of workload identities or service identities today. One is the managed identities, which is in Azure, we have this notion of a managed identity where you don't have to manage the credentials for them. The platform manages credentials for you. And it's available when you're running in a compute environment in Azure, such as an Azure App Service or Azure Functions. And then there are application identities, which give you additional capabilities on, such as allowing a user interaction, cross-tenant access, and all of that. And they also have secrets that you can manage on your own if you need to. So those are the 2 kinds of workload identities that we have. And you may see more forms of identities for workloads coming in the future, but these are the 2 that we have. So with this definition of workload identities, now let's dig into what we mean by workload identity federation. Workload identity federation is a capability that is currently in public preview for Azure AD applications. And what it allows you to do as a developer is to access Azure AD protected resources using tokens issued to your software workload by another identity provider. And we'll walk you through some very specific examples, such as Kubernetes being the identity provider, or GitHub being the identity provider, or Google being the identity provider. So what is the problem we are trying to solve here? The big problem that happens a lot of times is that developers, in a lot of cases, have to manage secrets on their own. So these are when they cannot use, for example, in the case of Azure AD and Azure, if a developer is running a software workload in an environment outside Azure, they cannot use managed identity. So the big problem that many developers face is that when they cannot use something like a managed identity because they may be running in GitHub and accessing Azure, and so they cannot use a managed identity there. They may be running in a Kubernetes cluster, which is not a Azure compute resource. It may be, and the Kubernetes cluster may be running anywhere, on-prem, in GCP, AWS, or Azure. And so in those cases, when they're trying to access Azure resources, they end up having to manage a secret. And the secrets management is not a simple problem because what happens is secrets last for a limited lifetime just so that they don't get breached. And so if you don't go and provide the right hygiene, a right discipline for these secrets, what happens is they expire. And when they expire, your service goes down because the service can no longer access those Azure resources. Or if somebody walks away with these secrets, or somebody gets access to the secrets, now they have access to your resources, and that's also not desirable. So for all of these things, just like for users, we are trying to get to the passwordless world, the same applies to workloads as well. And so this topic today is, how do we make it easy for developers not to have to manage secrets in certain scenarios? And the number of scenarios we can do this will keep on increasing. But today we can support this in a specific set of scenarios that we will walk you through in a little bit more detail. So to make this a little bit more concrete for you, I'll walk you through a Kubernetes flow of how this would work. So imagine that this is a Kubernetes cluster and there are multiple pods running, and these pods are all running in different namespaces even. What Kubernetes has provided is the ability for the Kubernetes cluster itself to become a token issuer and issue tokens to the workloads running on the cluster. And you can also have the Kubernetes cluster publish an OIDC discovery endpoint where any identity provider can validate tokens issued by that cluster. So I'll walk you through how this works conceptually, and then we'll look at a few more details. So first thing is, you set up a cluster with OIDC federation and trust on Azure AD app. So every cluster, if you're using a managed cluster, such as Azure Kubernetes Service, or EKS in Amazon, or GKE in Google, each of the providers have their own way of how you can make that cluster an OIDC provider. But you're managing the cluster on your own on-prem, then we also have guidance for you on how you can configure your cluster to be an OIDC provider. So once you go and make the cluster an OIDC provider, you can go and pick an Azure AD application in your tenant and configure it to trust a specific service account in this cluster. So in this example, I'll walk you through every specific example, but here I said for this Azure AD application, trust this issuer, which is this cluster, and this particular subject name, which is the service account in a namespace in a Kubernetes cluster. Once I did that, I could then go and deploy my service in a service B in a pod and tell Kubernetes that I need a token for my service account that I'm using in that service. At that point, what happens is Kubernetes starts issuing a token at a specific file location. And what the developer can do is then use our identity SDKs that we supply, both Microsoft authentication libraries, as well as Azure identity libraries. The developer can use either one to access Azure resources. And when they do that, these identity libraries will automatically take that Kubernetes issued token and give it to Azure AD and say, and I'll request an Azure AD access token in exchange. What Azure AD will do at that point is validate that the token is valid. It goes to the OIDC discovery URL for that issuer and checks, was this token signed by that issuer? Is it still within the timestamp that is marked in that makes it valid? And it also checks the Azure AD application, saying, is this particular issuer and subject trusted on this application? Once it has all the checks have passed, Azure AD will return an Azure AD access token, which then can be used to go and access Azure resources available to that Azure AD application. So this is the flow, and so You can use this today, and I have a blog post where it will provide you a detailed walkthrough that you can just go step by step. But there are really 4 parts, and I have a very quick, I will inspect a few things in this presentation today. We'll inspect exactly how my cluster looks like and all of that, so you get an idea. But there are really 4 parts to get this working end-to-end. First is the cluster administrator has to configure the cluster to issue tokens and make it an OIDC and publish an OIDC discovery endpoint. And they do this either by using a tool provided by one of the cluster managed clusters, or for the cluster they're managing, they can follow some guidance saying how they can go and do step number 1. Once they do step number 1, the developers can then configure the deployments to use Kubernetes service accounts and get tokens issued to the services running in the Kubernetes clusters. And they can also go to their Azure AD applications and configure the trust to trust those tokens issued to their pods. And once those steps are done, then their code during runtime then can take that Kubernetes token and exchange it to an Azure AD token. So that's the flow that you will see in this blog post as well. And I encourage you to get it, if you want to try it out, I encourage you to try it out. What I'll do right now is just walk you through a few things that we can look at. So you get it. It's more of a conceptual walkthrough. I wouldn't call it a demo, just because we don't have a lot of time here for a demo. So what I'll do is I'll show you specific parts of how things are working so that you get an idea. So the first thing is what we'll do is we'll look at. So we look at this cluster that I've set up. And if you look at this cluster, it says this behavior is modified by a preview because I'm using the preview in Azure Kubernetes service to try this out. So you'll notice that one of the things in this, when I did a AZK show, you'll notice this particular part, which says OIDC issuer profile is enabled and the issuer URL is this is the issuer URL. So this Kubernetes cluster, I have gone through the instructions in my blog post as well as in the Microsoft documentation as to how you can enable this cluster using the preview that's available in AKS. And I made this a OIDC enabled cluster. And that has caused this to go and publish a URL at that particular endpoint, which provides all the OIDC discovery components to it that allows Azure AD to go and validate, is this a trusted issuer, and validate the tokens. The second thing we'll do is we'll look at the Azure AD application where I set up this trust. So I'm in this Azure AD portal. And if you look at this portal, I can now, if you look at the, and I'm on an application in the Azure AD portal called Code Samples Federated Creds. And if you look at this application in the Certificates and Secrets tab, you'll notice that this app does not have any secrets. I'm not configured any secrets to this. All I have is a few federated credentials. One of them is this Kubernetes credential. And what I've done is I've said, in this federated credential, I've said, look, this is a cluster URL that identifies that cluster. This is my namespace, which is where my pod is running. And this is the service account name. Demo SA is a service account name. And that causes Azure AD to automatically create the subject name in this particular format, which is how Kubernetes will stamp it in their tokens. Kubernetes puts system, service account, namespace. In my case, the namespace is demo K8, and then the service account name, which is demo 8 SA. So this is what I did to configure the trust between an Azure AD application and the Kubernetes service account. So once I did that, now we'll look at the next part, which is how did I then go and ask Kubernetes to get me a token, and how does the rest of the stuff work? So one of the things that the Microsoft containers team has done is published open source components that allows the configuration to be very simple for a developer. Because normally what you have to do is you have to put a bunch of environment variables and also tell Kubernetes where to issue the token, what is the audience in the token, how's the lifetime of the token. There's a lot of configuration you have to do. However, there's a mutating admission webhook that makes this super simple. And I'll just show you very quickly on what that will look like. So this is my Visual Studio, where I have the service account that I'm using. And what I did was I said, demo Kate is my namespace. This is the name of my service account. And what I also did was I added a bunch of annotations and labels. And this annotation said the client ID, this is the ID of my application that I just showed you. This is the client ID that this service account is connected to. This is the tenant ID that I'm connected to. And once I did this annotation, what happens is this annotations are consumed by that mutating webhook. So once I enabled the Kubernetes service, my cluster with OIDC, I also ran a script to add the mutating webhook on my cluster. Again, if you look at the blog post, you'll see the specific steps to enable that. What happens is when a pod with this service account runs on that any node, the mutating webhook automatically looks at this annotation and populates the necessary parameters required for that pod to get the token. So for example, this is what my deployment looks like for my pod. And look how simple this is. This is just, I just said, this is my image. And I just said, this is, I'm running it in a federated environment. This is all the things I needed. I did not have anything else here to go and say, where is the token issued? What, other than I said, I'm using this service account. Now, what happened is when this pod got scheduled to run on a particular node, the mutating webhook automatically goes and says, for this particular service account name, since there's an annotation, it modifies the deployment to look as follows. So all of this was automatically injected by the mutating webhook, so you do not have to do it yourself. Now, of course, you can choose not to use a mutating webhook and add all of this yourself. But what the mutating webhook did was it said it used the information I had in my annotation and populated the client ID, the tenant ID. It also indicated where the token should be issued and added the mount point that's required for Kubernetes to issue the token. And it also said, who is this token for? We said, this is the token is meant for Azure AD, and the lifetime of the token is an hour. So all of this was simplified simply because you added 2 annotations on that service account. So now let's go back to our presentations. So we looked at the cluster, we looked at the service account annotations and all of that. Now let's look at the pod to see how things are set up for the pod itself. So I'll go back to my command prompt. And if you look at my pods, I have these 3 pods running. And when I look at one of the pods, you'll notice that it's got all of these environment variables set up, especially these things. These are all configured by the mutating webhook so that you do not have to do any of this yourself. And then once this is running, now my code here can then get that token and use that to get access to Azure resources. I'll just show you a very, a quick example of how that even looks like in my setup. So all I did was in my case, you are familiar with Azure Identity. I simply said, just go and use the default Azure credential. And that's all I had to do. As we have different types of credentials for you. I'll show the same code I'm using to demonstrate a Swifty credential, a Kubernetes credential, and all of that. So one of the examples that I have is how a developer who's already using code that uses default Azure credential, using Azure Identity, if they did that, they can continue using it because this default Azure credential has been updated to read the environment variables that we just saw. And then once it sees that environment variables, the Azure Identity SDK will automatically take those environment variables and pass it to Azure AD and get an Azure AD access token. So I have similar examples for how you do for a Swifty credential, GCP credential. Those are slightly different. But the simplest example I have for you is just use the default Azure credential if you're familiar. And as long as you're if you're running in the Kubernetes cluster, all of this works. But if you're running in GCP, then you have slightly different instructions that you can follow. So with that, let's jump back to our thing. So hopefully, this conceptual walkthrough gave you an idea of how you can set up a cluster with the federation, how you can set up Azure AD to trust a Kubernetes token, and how you can even write your code to go and indicate the service account you want to use and use the annotations to simplify your configuration using our webhook. And once all the configuration was set up, the code that you write is very simple in how you can get any Azure resources through this flow. So the next example I have is, and we'll go through the rest more quickly now that we have firmly understood the model. The pattern remains the same. All you're changing is what is the trusted entity. So Swifty is another piece of technology that some customers choose to use. It has some attractiveness for developers. So we'll just go through this flow. So in the case of Swifty, you can use Swifty is a set of specs for standardizing what a workload identity would look like in a cloud neutral world. And so in this world, what you can do is you can set up Spire is the implementation, is a reference implementation of Swifty. So you can set up a Spire server and enable it to be, to have the OIDC discovery URL, very similar to what we saw so far with Kubernetes. You can be running the Spire server in your Kubernetes cluster itself or in a different Kubernetes cluster. So that nice thing here is you can even have multiple clusters and all supported by a single Spire server. And the model is very similar. Once you have the server set up, then you can go and say, you can have a service and you can say that uses a workload API to request a Spiffy jot token from the Spire agent. So in this particular model, the same service I ever had running in my pod would request it for a token for my Spiffy identity that was assigned to me based on certain characteristics. Based on workload attestation, it got a identity, and I got a jot token for that identity. And then I exchange that token. I send that token to Azure AD because I've already gone and configured my Azure AD app now with a new set of the new federated ID credential. It says the issuer is the Spire server and the subject name is the Spiffy ID. And then once I did that, I can, when I send that token to Azure AD and say I need an access token back, Azure AD checks again, goes to OIDC discovery URL for that Spire server, checks that the token is valid. It also checks that the Azure AD application has its trust. It also makes sure that the token is within the lifetime. And after it's satisfied with all the checks, it comes back with the access token for Spiffy. And then you can use that token to access whatever resources is available to that Azure AD application. And some customers may choose to use Spiffy. It's another option. The attractiveness for people with Spiffy is they may be running on-prem, they may be running in multiple places. So they feel that there's a single model that they can apply to multiple things. So while it's a little bit harder than just turning on an OIDC on a Kubernetes cluster, it may meet the needs for depending on what you're trying to do. It also provides certificates so that you can do mutual TLS between your services running the pods, supports multiple clusters, and so on. And from the perspective of the workload ID federation, for us, it's very similar to what a Kubernetes cluster with an OIDC discovery URL looks like. For us, it's just a different format of the Spiffy identity and the server. So let me just show you quickly what that looked like on my federated credentials. So if you notice, again, I had multiple credentials, one for GCP, one for Kubernetes, and all of that. So this is the one that I had for the Spiffy. So this points to the Spiffy server that since I set it up, I provided this URL to my Spire server, and this is the issuer. And then this is the Spiffy identity that was assigned to my workload. And so I configured the trust to look like this. So again, go and, there's a separate blog for Spiffy as to how you can set it up and use it if you just want to try it out. The third model that we'll go through is GitHub. So GitHub is one of the things that a lot of developers use for their, setting up their repositories and all of that. And then a lot of DevOps and developer teams use the GitHub actions to go and deploy. Once as they check in their code, the CI/CD pipeline kicks in to go and deploy that service into the deployment, either in Azure or wherever it is. So what happens in a lot of cases is, since GitHub is not cannot use managed identities, many developers have to go and create a service principal, give it access to their subscription, and then take the secret of that service principal or that app registration and put it in GitHub, in their GitHub repo as a secret. And so a lot of customers are worried that, hey, you know what, that secret now, we do not want people to take secrets from our tenant and put it in outside resources like GitHub because they're worried about the security consequences of that. So in this model, what we allow is that if you're running in a GitHub repo, you don't need to have that copy that secret from Azure AD anymore. And so let's look at the flow that happens here. So when you go to GitHub, you can configure, again, you can go, and GitHub has a specific format for the subject name, just like we saw what was in Kubernetes, we saw in Swifty. GitHub has its own format. It has repo name, and then refs branch name. And it has like a couple of other options that are available to you. But the issuer is token.githubs.actions.github.usercontent.com, and then the subject is your specific repository. So you come to Azure AD and you again set up the trust on your Azure AD application. So instead of taking a secret and copying it into GitHub, you go and set up this trust saying, this particular application is trusted on my repository. Then you write your actions in a specific way that tells GitHub that you need a token for your actions workflow. So once you did this, GitHub starts giving you a token, and then that token has all the information that you're configured in the trust. So now the next thing that you do is you use an Azure login action. Actually, it's Azure login v1 action supports it. I just put OIDC support just to make it clear that this login action supports the OIDC flow. So the login action notices that you're using tokens in this flow, and it takes that token issued by GitHub and passes it to Azure AD. And Azure AD does all the validation it needs and then returns back a token to the Azure login action. And at that point, the Azure login successfully logs that actions in to that subscription. And then the whole web apps deploy action or whatever action else, the next set of actions that you have happen successfully against your Azure subscription because your application has access to that subscription. So again, this is another flow that is available in the blog post that you can look at. It walks you through the specific examples, and it also tells you how this works behind the covers in GitHub. Gives you a lot more details there. And then my last example here is federating with Google Cloud. So one thing that, one of the things that that you'll notice as we continue with this pattern is that wherever you can get an OID, our goal is that any provider that can give you a JAW token for your software workload, and any provider where we can validate that token with an OIDC discovery URL, we'll be able to support it. So AWS is one place where we are still looking at how we can enable this because they have a slightly different way how they issue tokens and all of that. And so that's not something that, today what happens is that OIDC discovery URL has to meet expectations that Azure AD has on the format. So we'll keep testing other providers and keep adding more providers and more scenarios to this list. But these are the things we have tested so far. And if you have others that you have feedback on, let us know, and we will continue that journey. So in the Google case, what happens is, again, you want to enable this without needing secrets. And in Google, what you can do is when your application is running in the Google Cloud, you can ask Google to go and give it a token for a service account whose keys are managed by Google. So you don't need to manage keys again in the Google Cloud. So first you go and create a service account and have your application use that service account. And then you can go to the Google Cloud and say, hey, what is the identity of that service account? And once you know that, you can come to Azure AD and say, on this application, the issuer is accounts.google.com, and the subject is whatever Google has this, I think, 16 or 20-digit numeric identity for a service account. You put that, and at that point, you can then exchange a Google-issued identity token for that service account to an Azure AD access token for this application. So then you can go and get a ID token from Google in your code, and then use that, and then use our identity SDK libraries to go and exchange that to an Azure AD token. So very similar format. You got a Google token, and then the identity SDK is allowed you to exchange that, pass that token to Azure AD. Azure AD then checks, is this app trusted for this particular token? And it goes to the Google's OIDC discovery URL and validates, was this token issued by this provider, and is the token still valid? And once all the checks are satisfied, it provides the Azure AD access token for that particular application, and you can then access resources that are accessible for, that have been granted access to that application, such as Key Vault or any other Azure resources that you have explicitly granted to that application. So that's the fourth flow that we walk through. And again, if you have any questions, raise your hands. We can, address any questions right here, or feel free to, ask us questions later on as well, and we'll make sure that that gets answered. I just want to, yeah.
There are a couple of questions in the chat. I can bring it up. And so first one from Nanasikar. Will this flow even work for Azure AD B2C tokens?
So this flow, maybe if we can get a very specific clarity on the Azure BTC tokens, exactly what you're trying to achieve through that flow, we can answer that question. There are certain, today, we do not have this flow working between two Azure AD applications. But we are looking at what are the things we should enable. For example, if there's a managed identity that you have token for, you have a token for, can we exchange it to an Azure AD application? So today, this is only supported on tokens that are applicable to workloads, so managed identities and Azure AD applications. So I would say my straight answer is for the Azure AD B2C, no, it won't be supported. But if you say that, hey, this is my scenario, this is what I'm trying to achieve, then we can look at it and say, what's the best way for us to enable that scenario?
All right. Another question from Carlos. Do the tokens expire? For example, client secrets, he believes they will last for at most 1 year, and they need to be updated after that. Do the tokens bypass this issue? Do they never expire?
That's a great question. So I think there are two parts here. One is, let's go back to the portal, just so I can answer this question properly. So if you look at this portal, if I go to certificates and secrets, when I do client secrets, when I add a new client certificate, it's got a certain expiry time. It says expires after 6 months. So I can go and do all of this, and then after 6 months, if I did nothing, it expires, and if I have a service running, it breaks, and I have to go and reconfigure that secret and all of that. In this flow, this federated credential, it's not a secret anymore. There's no secret here because these are all these are all public information. So, for example, this is just an OIDC URL. This is a identity. So there are no secrets here. So this credential, what we call a federated credential, never expires. So this is, as long as you keep it, it's there, and it never expires. However, what happens is, in the flow that we saw, let's go back to this deck. In the flow that we saw here, the Google token has its own expiry, right? Google, when it issues a token, you get a token probably for an hour or so. So when you pass that token to Azure AD, you need to make sure that you get a token that is reasonably recent. Otherwise, if you take a token from Google and then exchange it a few hours later, then Azure AD will say that token has expired. So that token will expire. So you need to get, in your code, you need to get a token at around the time when you need that, when you need to make that exchange. And then when Azure AD gives your token back, even that token has a lifetime. And that token lifetime is typically an hour, but you can configure that in your tenant. And so let's call it an hour for this purpose of the thing. So imagine that you have a Google token and you have been using that. And then after about an hour, when it's about to expire, you got to get an Azure AD access token. That Azure AD access token is valid for an hour. And after an hour, that token expires. And then if you need it again, then you have to go through that flow again to get that token. If there's any follow-up questions, let me know. I hope that clarified how this works.
Hey, Uday, I do have a follow-up question. This is back to the Azure AD tokens for Kubernetes. So I did not actually ask that question, but I do have the same question. And I'm kind of curious why it wouldn't work for B2C issued. I mean, a lot of our customers are registering, have the apps only for their B2C tenants. So maybe if you go back to your Azure AD tokens for Kubernetes pods, your flow, the first flow that you walked us through. Sorry.
No worries.
There you go. I can kind of cut to the chase here. So See that step 2, if that Azure Active Directory is actually a B2C issued token, like on step 2, 4, 3, why wouldn't that work?
The reason it wouldn't work is because from the Azure AD side, we have built this feature to make sure that we can give proper guidance. Because we could, if we go and say, hey, look, we have just opened this up and everything works, then you'll have no idea what works, right? Then you have to do the testing. So what we have done is what we have done is we have
do the testing for me.
So what we have done is we said we have to be careful here, because anything is possible,
right.
And we can, and instead of telling the world anything is possible, we want to go and actually make sure that we can give proper guidance on how this works. So we have actually gone and looked at how we can enable Kubernetes, GitHub, and all of that. And like I said, even for AWS, I can imagine how it works, but if you try it, it won't work because Azure AD has not enabled it yet. And the same thing, if you have tenant to tenant, especially with Azure, between two Azure AD tenants, we have not enabled this particular flow yet. But it's good feedback from you. So are you saying
that would be a use case we're seeing more and more of,
So can you help me understand that part? Like what is somebody doing? Is there an application in the Azure AD in the B2C tenant that needs an access to get a token to an Azure AD application in a tenant?
Yes, currently most of the folks I run across are managing secrets, which we want to get away from. And they have a separate cluster, even namespace, really, to for that customer-facing application, and then they have their customers in their B2C tenant. So they just kind of want to segregate everything over into that area. I think sometimes that's because of some compliance controls also that are in place on that. So you have to keep all these things separate. So anyway, I'm just trying to model this approach to those scenarios. I guess I'm going to have to build a lab and test it.
That's a good question. I can tell you already that, before you test it, I can tell you already that it is not supported right now, but that's good feedback. Why don't I do one thing? We will go and, actually work with the B2C team to make sure that we can go and validate this end to end and then see how best we can bring that guidance out for you.
Yeah, or if there's some other way to swim up that stream, let us know. Yeah.
Sounds good.
Okay.
Is it okay for me to reach out to you later on just so that I can get the specific and so that we make sure that we are testing the right set of things?
Yes, sir. Okay. Yes, sir. Uday, thanks.
So then let's walk back. And by the way, any other questions, feel free to keep asking. So what's next in this area? So what we're doing is just like you saw all the things that we did with Azure AD applications, we are adding the federation support for managed identities as well. So whether you choose to use an application registration or a managed identity, because managed identities are simpler for developers to create and use because they're all part of the subscription. So we're going to add the support for managed identities as well, so that you don't have to, in some organizations, developers have to go and ask their IT admins to get an application registration, and it's easier for them to create a managed identity. So since this is all about supporting our developers, we are saying we'll also add this for managed identities. And one of the things that I'm not mentioning here is also, we are also looking at policies that we need to provide to IT admins. So for example, some customers may not want the developers to randomly set any issuers as trusted, even though the developers may own their subscription. So we are looking at talking to the IT admins and the security folks to say, do you want a list of, by default, we'll say, anybody is allowed to add any issuer as long as they have the permissions to go and do that, which means that in the certain role, like the managed identity contributor role or the app admin role. But in addition, we want to make sure that the security administrators they can go to a tenant and in the tenant level say, I only want these issuers to be used in this tenant. And then we can enforce policies of that kind so that if a developer wants to go and configure something, they have to go and convince their IT admin as to why they're secure. Because remember, we got rid of secrets that a developer needs to manage on their own, which is a hard problem. However, now since the identity provider itself is now you're making the Kubernetes itself the identity provider. Now, if you don't manage the keys on that identity provider, the signing keys, then that's also a security risk. So as long as you're using a managed service like AKS or EKS or GKE, where the cloud providers are managing those for you, then it's not a big problem because they can rotate the secrets and all of that. But if somebody is running their own cluster and they're not having the hygiene, they're not keeping the secrets in a, they're opening up their etcd database to the internet and all of that, which without even knowing, then it can cause some security issues. So I think those are the places where you may have to convince your IT admin saying, look, this issuer is managed well, it is managed by me in this fashion and all of that. And that may convince the IT admin to go and add that issuer into that list. So we are thinking about policies like that. So if anybody has feedback saying, hey, I wish we could do this, I think we would love to hear that. So we are also looking at how we can make this built into the Azure Kubernetes service itself. So once we have the managed identity support, we also have this capability called pod identity, which is a GitHub project, which is in AKS. We are going to update that to use the Azure AD Workload Identity Federation because it's a more native model without having to create custom resource definitions and all of that. So the future of AKS, you'll see this built into AKS itself, so that when you say turn on federation and turn on workload identity federation, then the cluster is all set up for you. Even the mutating webhook, everything is set up for you, so you don't have to do anything at all. And then you can just run your, go through the rest of the flow without having to do all the setup that I walked you through. And then finally, we want to make this whole federation. Right now, it's in public preview for Azure AD apps. Managed identities, we are still working on it. Our goal is to make all of that generally available so that you can put this in production. So that's mainly what I had for today. Thank you so much for joining, and hopefully this was interesting to you. And as I mentioned, if you have any feedback, if you have any scenarios that I'm not covered, like what I heard about Azure AD B2C, please feel free to jump past questions right now, or even feel free to give us the feedback later on through Stephen.
Oh, there is one question coming up from Carlo. Could this work in partially online scenarios, such as where a Kubernetes cluster has intermittent access to the internet?
That's a great question. So there are two ways I'll answer this question for you. One is, since that token is valid, so once you get it, so in order for you to get a token from Azure AD, Kubernetes will issue a token to you, but in order for you to get a token from Azure AD, you need to be connected to the internet. So, and once you get the token for the next hour, while that that you're using, it all depends on what that token is used for. Because even if I give you a token, if you're trying to access an Azure storage resource, and if you don't have internet connectivity, you can't even get to that resource. So the important thing to understand is, what are you going to do with the token? And if you're trying to use a token to access other cloud resources, then you will run into problems if you don't have internet connectivity. So that's the simple answer. But here's one of the things that we are also looking at. Imagine that internet connectivity is not the problem, but imagine that regional connectivity is a problem. For example, you're running in this region, and that region may sometimes lose connectivity to the rest, that if that has connectivity issues. What we're looking at is how can we make Azure AD more regionally available, so you don't always have to go to a central resource like Azure AD directory and get these tokens. So in that model, what happens is you may be running in an Azure region somewhere. Your Azure storage is in that region. And let's assume that region, for some reason, got disconnected from the other regions. Your app will still run. As long as you have, that you're able to be within the region, you can access the Azure storage within the region. Your Kubernetes cluster will get a token from that regional, what we call STS, that regional Azure AD, and everything will work within that environment. But if you are completely on, let's assume you're completely on-prem and your entire internet got disconnected, then you can't even access any of the Azure resources through this token. So then giving a token is not going to be very useful in that model.
Just to answer your question, in our scenario, the applications would be all communicating locally in the cluster. We just want to authenticate with Azure AD for IDP.
I see.
The challenge is not being able to have an offline Azure AD, right? So that's where this is interesting.
That's a good question. And when you say offline, like where is your thing running? Is it running in a completely sandbox environment without any X?
In the ocean on something that's
Oh, in the
floating
ocean.
and has a VSAT connection.
So I think one of the things that we have thought about, and I think this is more brainstorming. I don't have any things, but imagine that the regional Azure AD is packaged in a device and given to you. Then I think that would help you, right?
Yeah. Yep.
Yeah. So no, we don't have that, but something for us to consider as an option.
Okay. Thank you.
That's a great question. Anybody else?
No other questions that I can see. Thank you, everyone, for joining us today, and thank you, Uday. This was great.
Thank you for that opportunity, and thank you for joining.
Thank you, everyone. Have a great day.